Your screen is not moved on.
It is in the title. I'm explaining about the title.
Okay, okay.
Okay. And see, but the AGV do not pick or move anything, but the unmanned vehicles can easily do it. Hello?
Yes,
In our
yes,
project, we have describing the dual resource. Hello, sir.
Yeah, go ahead, man. Go ahead, audible. Yes, Yoshika.
The implemented. The last dual resource concept is receiving the task order and picking the station to network. While the implementation, the layout is to minimize the cost and complete the task in a short time. Yes, in this we have used a dual resource coordination algorithm. See, what is the principle we are using means it will pick the object and receive the task orders from the picking stations. See the how the task will be given to the stations, but it will receive through the network. So how the AGV has been designed means the AGV design will determine the number of AGVs we use and how many number of picking stations are there, and also the location of picking stations will also be determined. For example, I will say one example. All of them know about an Amazon Orange Kiva system. It is nothing but an Amazon robotics. See, it is in the same way as our project. It will lift the stack and it will move the respective stack to the destination places. So there will be elimination of workers. So it will be very easy for them to maintain and replace the stack.
In warehouse, there is a huge amount of material is available. So we need more worker to maintain this material for picking, packing and shipping, etc. In order to manage the warehouse, the half of the profit is given to the laborers. But in order to reduce the labor cost, we implement the UAV. The principle of the AGV is first of all, it receives the order from completely store the material and shorting the task.
Next is an existing system. See, these are the existing systems we have been used. First of all, dual heuristic algorithm. It is also known as a dual genetic algorithm. Here there is a three methods. First of all, the selection, crossover, and the mutation. In the selection process, we will select the best individual for doing the operation. In the crossover, we will find the better solution based upon the parent group. And in the mutation, we will find the exploration of algorithm and how it can be used. And next is an harmony search algorithm. It is nothing but an algorithm that is used to transfer the materials based upon the control machines. See, normally the AGV are a non-deterministic. So increase the productivity, we can use this harmony algorithm. Here we use the two indicators, that is the time and the distance. Next is a quadratic programming. See, normally the path planning for UAV are still more difficult in the space because it can be adapted to the static environment, but it is not adapted to dynamic because the moving environment, the UAV cannot be fixed and the plots will be more difficult. So we can use a three-dimensional space to avoid that static and dynamic obstacles. This is known as a quadratic program. And next is a particle swarm optimization. It is also known as a PSO. This is used to find the maximum and minimum function for a multi-dimensional space. And also it gives a result as a efficiency. Using this efficiency, we can alter or adjust the AGV according to increase the efficiency. And next, this is the disadvantages. First one is in this process, we cannot specify the particular location or particular area. But in our project, we have been cleared this disadvantages, and we have we can specify the particular location and area. Inside the system, we are considering storage racks, picking robots,
control system. The outer master control is used for sorting and picking for our purpose. There is used for the task scheduling algorithm. It's used to optimize the equivalent task scheduling. It is based on equivalent configuration and feeds the result back to master control. In this project we used two scheduling strategies. That's one task scheduling strategy. The fifth job task priority strategy. In this for appropriate number of AGVs, we was configured an unmanned warehouse, and the picking station is based on the build rate and to minimize cost.
It's a block diagram. First of all, we are going to scheduling the task. Scheduling the task means nothing but when we are giving the task to the unmanned aerial vehicle, it take the decision regarding the allocation of availability of capacity, regarding storing the things or whatever the things we are giving or whatever the task that is given. And next, sorting. To take the decision of capacity, it should make a sorting things. It should keep parallel arrangeable moment and to categorize the things in the warehouse is to replace the items which is given, and the equipment optimal configuration. Configuration is nothing but measuring the space you have that we have to work. By getting the task, it should decide whether the task is suitable for the given place or valid place. Next one, optimization. It clearly defines the clear-cut shortage and sorting and office and shipping allocations. At last, fitness analysis. After conducting these processes, whether the process till now is conducted is correct or not, it checks it makes the crossover techniques, and finally complete the task. The software requirement. In this project, we are using the MATLAB software to stimulate our project. The advantages of our project is in the previous nothing but the existing one, it is getting the lag of locating the location. In our things, by using the 2-layer of genetic system, we take over this. We had overcome this disadvantage, and this is a main advantage, and we can we can complete the task within a short period and higher reliability, and it is a work efficiency is available.
The next conclusion. See this in our olden days, the warehouse used a man to good product way, but nowadays it has become an unmanned warehouse. So it is more efficient and it will be more cost efficient too. So we have to adapt to the new characteristics. Every day the warehouse layers are being designed to meet the storage needs of different types of goods. Nowadays we are storing more items, so maintaining by a man is very difficult. While we are using this AGV unmanned, it is very easy for them to give in a flow way, and in the future the warehouse layers could be added to the schedule. In this we have been used a genetic algorithm, so we can easily improve the efficiency of this. And thank you.
Yeah, hello. Is it over?
Yes, sir. It's over.
Fine. The topic is good and nice explanation. I have to appreciate you. Fine. But what is that you have done? You nicely explained about AGV and unmanned warehouse. Fine. Like all the highlights and all you have shared. You have explained nicely. Fine. And good to see you gone for GA. All right. You talked about GA and many algorithms.
Yes,
it's all fine. But what is it you have done? It looks like a simple paper. You have taken some material from some paper, like a survey, and you are giving it in presentation. So what is your contribution to this? 3 or 4 contributed, fine. So
it is totally a stimulation project.
Okay.
So here we can, yes, sir.
But you have done something with the MATLAB, right? You explained. What is it?
Yes, sir.
Yeah. What is the MATLAB code? And
sir, it is an ongoing process, sir. So we didn't finish our project yet.
Okay, what have you finished so far? If it is half,
Just now,
what is the result so far? And maybe with the help of this block diagram, you can say where you are right. The scheduling
sir,
part sorting is over.
yes, sir. In the scheduling part, we have seen if a task is executed, the equipment configuration will be recorded, sir.
No, that's fine. That's fine. I understand that. But what is
Yes, we have been finished up to the equipment scheduling, sir.
the equipment scheduling? Okay.
Yes, sir.
That you could have explained. Like what is that you have done that you could have explained?
Yes, sir.
I was looking.
Yes, sir. Yes, sir. If we have done with up to an equipment scheduling, like when we are giving a task, the configuration will be recorded. If it accepts the task, it will be carried out.
That's fine, Ma. That's fine. Are you focusing on any hardware or what for this?
Yes, sir. Up to now, we have an idea only for the simulation.
Okay.
In the future, we can extend it in the hardware too.
Fine. So I understand you are in 8th semester and doing a project on this, right?
Yes, sir.
Okay.
It's our end semester project.
Okay, Ma. Carry on. But long way to go. But if you come out with some product or some experimental results, it will be better.
Yeah, okay, sir.
Fine. All the best. Good.
Thank you, sir.
Bye.
Thank you, sir.
Yeah, welcome.
Thank you, sir.
Fine.
Thank you, sir. Vairaprakash, sir?
No, ma'am, no question.
No question. Okay, sir. Okay, next presentation, paper ID 126, data transmission by multiplexing light spectrums based on RGB fusion method using light fidelity. Authors Ms. S. Yoharani, Mr. S. K. Rahul, Mr. K. Dayananda Ramana, Mr. K. Sadananda Krishna, Mr. S. Prabhu Kumar.
Good evening, all. I, Rahul SK, along with my teammates Yogarani, Dayananda Ramana, Sadananda Krishna, and Mr. Prabhu Kumar, Assistant Professor of Electronics and Engineering Department from Veritech Multitech Engineering College, are going to present about data transmission by multiplexing light spectrum based on RGB fusion method using light fidelity.
Rahul.
Sir?
I'm audible. Yeah, just take 5 to 7 minutes. You need not explain the basics of this topic. You don't need to give any theory and all. You can just highlight the work what you have done. What is your contribution will do? Go ahead, please.
Basically, existing light fidelity uses a white light spectrum, which carries only one signal data. But what we are contributing to in this presentation is our Li-Fi is integrated form that produce 3 spectrums simultaneously. That is, we can transmit 3 different data like audio, text, and video simultaneously. And that was our idea, sir.
Okay. Go ahead, please.
So, okay. When compared with the current technologies, like light transmission using light source, which provides the greatest speed.
Can you move your slides and explain? Yeah. Is there anything present in the slide or what? Can you just move and keep explaining? Yeah, objective is fine. You have any block diagram or any work you have done?
Yes, sir. That will be explained by our teammates.
Okay. Go ahead.
Shall I call her?
Please.
Tell her to explain it?
Yeah, please go ahead.
Good evening, everyone. I'm going to explain the implementation of the system. Okay. This is the block diagram of our system. It shows that different data transmissions, different signals are transmitted through different light signals, LED light signals, and it is modulated and multiplexed, and the signal is given to the channel, and the given signal is demodulated, demultiplexed, and the demultiplexed signals are demodulated and given separate outputs and separate signals. It reduced the time taken by the Li-Fi because we are using 3 different LEDs at the same time. So it is reducing the time. Next. I'm gonna explain the transmissions in separate signals in separate manner. At the beginning, first I'm gonna explain the text transmission. In text transmission, we use green LED to indicate the text signal. Here there are two sections in this. First, the transmission section and the receiver section. In transmission section, we have computer to give the text input and Arduino board which we use input and output programs inbuilt to transmit the data, and we use red LED to transmit the data via light signals, and it is given to the modulator modulates the signal and give it to the channel, and it demodulates the signal and give the output on the text output device. Next, I'm gonna explain the audio transmission. In audio transmission, we use two sections. In transmitter section, we use audio player to give input and aux cable to connect the audio input and modulator. And in receiver section, we use aux cable and audio output device. Here we implement that we give the audio signal in the audio player, and it is given to the aux cable to the modulator as a photo detector. Solar panel is attached in the receiver side. It detects the solar light. It detects the light waves and it demodulates the signal and give the output on the other side in a speaker or any output device. And the next is video transmission. The video transmission is done in 2 sections. The transmission section have two important things. One is computer and the LAN cable. LAN cable is used to connect the computer and modulator. We are sending the video input from the computer through LAN cable. It is given to the modulator. It modulates the signal and shares in the light waveforms, which is blue in color. It is given to the channel, and the channel receives the signal and demodulates the signal and give it to the LAN cable. In the receiver side, it receives the signal and it gives output in the video output, which is another computer or laptop, maybe a PC. That's all the implementation. And the next, our teammate Dayananda Ramana will continue with the parameters.
The parameters are baud rate, which value is 38400. It can transmit data 38,400 baud rate serially. The baud rate is the rate at which the information is transferred in the communication channel. On seeing the bit rate value is 803 Mbps, because the simplest form of amplitude shifting is used to transmit the data by sequentially turning on and off the LED. The reliable communication range would decrease the low dimming level and increase the decrease in the brightness of the LED. Usually the distance between the LED and the receiver is up to 5 to 15 meters. It requires a line of sight. Distance can be increased by changing the LED wattage. High intensity LED can transmit more distance. On seeing the frequency of Li-Fi, the value is 430 terahertz to 770 terahertz. Visible lights fall in the range of EM spectrum between the infrared and the UV. It has a frequency of about 4 into 10 to the 14 and 8 into 10 to the 20 cycles per second. On seeing the wavelength, it has the wavelength of value 380 nm to 740 nm. The bandwidth of the Li-Fi is 340 terahertz. The bandwidth of Li-Fi signal is up to
default which is given by reducing the lower cutoff frequency from the upper cutoff frequency. The advantages of the RGB fusion Li-Fi system is less transmission time, number of channels are increased, LEDs are easily available, non-expensive, faster than Wi-Fi, do not cause health problems as the electromagnetic waves and radio frequencies can cause health problems. No magnetic interference is possible in this Li-Fi system. On drawbacks of the RGB fusion Li-Fi is it requires only line of sight. It requires a wall or a reflecting mirror to transfer the lights from one region to another. It can be used within in a closed room. On seeing the applications of RGB fusion light fidelity, it's CL communication. In CL communication, urban environment use the Li-Fi enables.
Yeah, Krishna.
Hi, sir.
Yeah, please go ahead. Can you just move to the next slide? I understand. I could read the application slide. Is there anything you have beyond this?
No, sir.
Okay, then leave it. I'll ask a couple of questions. It's a good topic, actually, topic of future, I understand. I could see some photographs, whether the photographs are taken from your lab or it has been taken from your any source, any standard paper?
Sir, it's taken from my lab, sir.
Lab. Okay, then if that is the case, what is that you have done? Is it your experiment or what? If you could go to lab. Yeah,
one of our experiments, sir.
Very good.
Normal Li-Fi systems where only white LED is used to transfer the signals, whereas in this R Li-Fi system we use RGB fusion method on using a red, green, and blue signals to combine the white signal and we transmit the signals. The existing Li-Fi system has only single data, whereas the RGB fusion method has 3 kinds of different data.
Okay. So for this, how much distance you kept actually between the laptops? You were able
5 to 15 meters, sir.
50 meter, huh?
Yes, sir.
Okay.
It's a maximum possible.
Okay, so that was good. Okay, so just a couple of questions, basic questions. How do you differentiate Li-Fi from Wi-Fi?
Wi-Fi is an EM wave, sir. Li-Fi is a visible light.
Visible light, which is better to use in practice? Wi-Fi or Li-Fi?
Wi-Fi is also possible in future experiments as we can use in street lights. We can use separate IP address to use it in smart city projects and also.
Okay. My simple question is, which is faster in terms of speed, Li-Fi or Wi-Fi?
Li-Fi is faster, sir.
Okay. What is LOS? Can you define LOS? Somewhere you said LOS.
Line of sight, sir.
Yeah. How do you define it? What is it actually? What do you understand from the term LOS?
The direct transmission of from the input to the receiver, sir.
Direct transmission. What does it mean? Direct transmission.
From the observer eyes to the distance points.
Okay.
Line between 2 points, the straight line between 2 points.
Okay. Thank you. All the best. Fine. Good luck.
Sir, if you have any questions, sir? Professor?
No.
Okay, next presentation. Paper ID 144, Variable Patch Antenna on Meta Surface Ground for 5G Applications. Authors Mr. T.N. Suresh Babu, Mr. D. Sivakumar.
So visible the screen?
Yeah.
Yes. So good afternoon to all. I am T.N. Suresh Babu, research scholar, under the guidance of Dr. D. Sivakumar, Professor, ECE Department, Eswari Engineering College. So my title is Variable Patch Antenna on Meta Surface Ground for 5G Applications.
Yeah, Suresh.
Yeah, sir. Good afternoon, sir.
Good afternoon. Since you are a scholar,
yes,
don't give any basics and all. Straight away, you can go to the work what you have done.
Okay, sir. Okay, sir.
Please.
Okay, sir. Thanks.
Just take 5 minutes. Will do.
Okay, sir. These are my contents: background, literature survey, problem description, methodology, results and discussion, conclusion, references. So in that 5G technology, the intensive research into 5G technology is a strong ignition of the methodological evolution meant to report the emergent demand and requirement for wireless broadband and IoT-based applications. So this 5G technology, not just for smartphones, but also numerous IoT devices will support the 5G technologies to enable the advantage of the faster transmission speeds, lower latency, and therefore increase remote execution capacity. So here, so my area is the wearable technology. It's a fast growing one, which is used in many applications, the military, healthcare, and also a consumable electronics. So they will also play a crucial role in the next 5G networks, which are expected to provide higher bit rates, fewer outages, and a broad coverage area than previous technologies. So in that 5G technologies, we concentrate sub gigahertz, sub 6 gigahertz, and above 6 gigahertz. So in that above 6 gigahertz, that is called millimeter waves, which are used in that wearables. So to design the wearable antennas in that millimeter wave, we consider this one a combination of topologies, component design paradigms, and also materials, fabrication methods, and assessment procedures for evaluation of that wearable antennas. The fabrication process has improved as an antenna as a progress from simple microstrip or planar monopole-based topologies to more advanced arrays and metamaterial-based topologies. So many technicals, technologies, that is a laser cutting, embroidery, metallized highlights, inkjet printing, and other techniques are projected for higher frequency millimeter wave applications of racers. So the parametrics, SAR analysis, deformance studies on detailed human phantoms, reliability studies, functionality test and operation under a variety of environmental circumstances are considered for the designing of the wearable technology. So it's a literature survey. Zoe et al. Proposed compact FR4 frame iterator MIMO antenna covered 4.9 GHz and 5.2 GHz. And Ducey et al. Author proposed compact liquid crystal polymer based tri-band flexible antenna covered all 5G sub gigahertz. And the third one, the Kamran A et al. Proposed a bus safety tri-band antenna on flexible FET substrate covered 5.3, 5.6 GHz and 5.0 GHz. This is also a sub 6 GHz 5G wireless communications. Muscat Alam et al. Proposed a meta-surface enabled heptaband compact antenna flexible polymer substrate that resonance has seven bands. Right? The Ulayas et al. Proposed the external shaped CPW fed based frequency reliable antenna using the FR4 substrate. Resonance only a sub gigahertz, 2 gigahertz, 2.45, and 3.0 gigahertz, 3.4 gigahertz. So these authors propose only the sub gigahertz operation of the wearable antennas. So now, Lai et al. Proposed a compact UW MIMO antenna FR4 substrate using that resonance coverage band is 3.3 to 10.9 gigahertz band. And Qasim S et al. Proposed a UW nanocellulose coconut coir fiber inspired antenna. Yes, sir. Yes, sir. Yes, sir.
You can skip all the
Yes, sir. Yes, sir. Okay, sir. So, these five authors proposed only the above 6 gigahertz applications. So my problem description is not much information is not available on meta-surface enabled multi-band planar antenna for sub gigahertz and beyond 6 gigahertz 5G application in a wearable scenario. So my methodology is designing a compact tetraband wearable textile patch antenna developed for sub 5G and beyond 5G applications, consisting of an inductive meta-surface ground plane and a slot filled patch. So I analyzed using the CST microwave student software the different parameters, S1 radiation patterns and peak gain, and also I examined under various bending conditions. Furthermore, the antenna performance evaluated various body locations and the specific absorption ratio performance modeled by CST ratio. So this is my antenna design. The antenna is developed on a 1.8 millimeter thick jean substrate with a permeability of 1.6. The overall dimensions are 30 mm to 42 mm. An inductive meta-surface ground is made up of a free 5x4 array of periodic square copper patches, each measuring 5x5 millimeter on the substrate. So this is the evolution of my proposed patch antenna. So first of all, I designed the antenna one the size of the 15 cross 17 transmission line equations that I got initially 6.5 gigahertz single band. So after that, I incorporating 2 rectangular parasitic patches under the patch, normal patch. So I got three bands. After that, by incorporating L-shaped strip incorporating the antenna 2 and also a second L-shaped strip incorporated additionally in antenna 3, I got a tetra bands. So this is the simulation results of my proposed antenna. In that simulation results, in that graph, the S11 response are better than minus 10 dB is achievable over 4 resonances bands. The VSW less than 2, say 4 bands, 1.9 to 2.4 and 3.4 to 4.2. So these are the sub 6 gigahertz bands. 19 to 21 and 24 to 30 is above 6 gigahertz, beyond 6 gigahertz bands. So these are the far field radiation patterns of the proposed antenna. Here I consider 4 frequencies, 2, 3 sub gigahertz and 20, 27 beyond 6 gigahertz. Provide the gains are 2.42 and 4.35, 8.05 and 9.15. So these are the directive pattern for the 4 frequency bands. And also these are the surface current distribution for these bands. So in that lower band, the main patch and the parasitic patches, in that area, the surface current is more distributed. But in that higher bands, the currents are distribution not only the main patch, that meta surface dominated. So these are the bending performance simulations. So here I bended my proposal antenna for different radius 8 mm, 10 mm and 12 mm. So in this bending condition provided that antenna resonance both sub gigahertz and also super beyond 6 gigahertz. So this is the on-body performance of my proposal antenna. So SR is a critical criterion for determining the amount of electromagnetic field consumed by human tissues. So in my simulation, the basic model of human tissues will their electrical properties, relative permittivity, conductivity, mass density and thickness, consisting of skin, fat and muscle, with SAR distribution at 27.28 SAR 5G millimeter wave frequency with an input power of 0.1 watt. So at a height of 2 millimeter from the tissue surface, the antenna is positioned. The peak 1 gram SAR value for patch alone is 1.16 W bar kg according to the simulated SAR distribution. This is less than 2 W bar kg. So this is my conclusion. A variable textile meta-surface ground-based patch antenna for millimeter wave application is presented, explored, evaluated, and simulated in this work. The topic of metric optimization for various antenna settings has been thoroughly studied. With VSWR less than 2, S1 response better than minus 10 B can be achieved 4 resonance band, 2 sub gigahertz and 2 above 6 gigahertz. The antenna design shown in this article has been potential to be very useful in 5G technology. The proposed antenna has a fair gain and good radiation characteristics according to the simulation findings. In addition, the suggested antenna is put a test under various bending conditions. So the measured results reveals that the addition to meeting SAR criteria, the antenna still had good matching and radiation patterns at the desired operating frequencies. So these are my references. Thank you, sir. Any questions, sir?
Suresh.
Okay.
Yeah. You already performed our
Sir? Sir?
Same thing? Yes.
Sir?
Suresh, audible?
Yes, sir. Yes, sir. Audible, sir.
Yeah. The talk work anything new?
Yes, sir. This is the new, sir. New one, sir.
Okay,
yes, sir.
Okay.
Simulation, sir.
Fine.
Only simulator, sir.
Oh, simulator. Okay. What simulator you used?
CST software.
CST. Okay.
Yes, sir.
So you try to fabricate any of the geometry or what?
No, sir. Going on, sir. The fabrication is going on, sir. Yes, sir.
For this geometry, for example, how did you calculate the dimensions? Copper foil is fine. How about the value?
Sir, first of all, I start with the first page, 15 cross 17.
No, that's fine.
Yes, sir.
Lower geometry, you have some dimensions, right? The numerical values, 12.5, 13.5. How did you calculate?
Using the transmission line model, sir, that width, length formulas, using that formula, sir.
Okay. How about the feed? What type of feed is shown here?
Here I use a coaxial feed, sir. Yes.
Coaxial. Any reason to go for coaxial or anything?
Simple. The fabrication is simple, sir, compared to other.
Okay.
Yes, sir. Yes,
but how will you validate your results? Okay, simulation is fine, CST is fine, but how will you check your results? Any mathematical modeling?
No, sir. Just a trial and error method.
You've been trying. Okay. So this will resonate at which frequency? Is it a 5G antenna?
Yes, sir. So in that results, the fourth band is a 24 to 30. It's a 28 gigahertz 5G, sir.
Okay.
Yes, sir. Yes.
So at this band, you get more efficiency, right? 23 band, 25. Yes, okay. Okay. So as of now, it is only simulation, right? You have to check with mathematical equations and validations.
Okay, sir. Okay, thank you.
Fine. All the best.
Thank you, sir. Thank you, sir. Thank you, sir. Okay, sir.
Sir, my one question is there.
Yes.
Sir, have you compared the result, sir?
No. Just I simulate my proportion. That's all. Not going the measurement. Yes, sir. Only completed the simulation work. Fabrication is going on, sir.
Okay, sir. Thank you.
Yes, sir.
Okay, thank you, sir.
Okay, thank you.
Next presentation, paper ID 152, simulation of circular microstrip patch antenna for millimeter wave applications. Ms. R. Sheila Rani, Ms. P. Akshay Shri, Ms. M. Nitya, Mrs. R. Manjula Devi.
Participants, please take 7 minutes for presentation.
Am I audible?
Hello, Nityashree.
Yes, sir. Am I audible?
Yeah.
No, it is audible. Take 7 minutes for presentation.
Okay, sir.
Shall we start, sir?
Yeah.
Kindly put your slides in presentation mode.
Press F5. Suresh Babu, sir. Suresh Babu, sir, mute பண்ணலையா?
Presentation mode la போட முடியல. F5 இருக்காக.
Hello, Nityashree.
Yes, sir.
Start your presentation.
Okay, sir. I can start.
Good afternoon, sir. We are from National Engineering College, Kovilpatti. We have done our project under design of circular microstrip patch antenna for millimeter wave application. In our project, we have identified problems in rectangular patch, and the problems are narrow bandwidth, high return loss, low power, and low gain. And our main objective is to increase the bandwidth and reduce return loss by using circular patch, and also to improve power and gain using array configuration. These are the literature survey we have undergone, sir. Next. Antenna array is a set of 2 or more antennas. In this antenna are combined or processed in order to achieve improved performance over a single antenna. The array can also be used to increase the overall gain, provide diversity reception, and cancel out interference from a particular set of direction. Over to Sheila Rani.
Just proceed.
Sheila. Okay, sir. Circular array. It's a circular array. It's another arrangement that is commonly found in a phased array and recently in microwave backbone arrays. The angle between the elements is assumed to be uniform. The circular array does not have any edge elements. we used here is millimeter wave frequency. The millimeter wave technology is just one part of the future 5G networks. The objective of the millimeter wave is to increase the data bandwidth available for smaller densely populated areas. Wavelength is between 10 millimeter to 1 millimeter. Then this is the circular array structure. This is a formula which we used to find out the radius of our patch. The F A is the radius of our patch, and H is the height of our substrate, and F is the resonant frequency, and epsilon is the effective dielectric constant of our substrate. These are the parameters which we used in our design to simulate our circular microstrip array antenna. This is our designed simulated circular microstrip patch antenna. This is our results we found out through the simulations. This is a written loss. Written loss is nothing but is the loss of power in a single return reflected by a discontinuity in a transmission line or a optical fiber. We undergo this results for two different type of substrates, for FR4 as well as a August Durite. For FR4, the epsilon permittivity is 4.4, and for an August Durite substrate it is 2.2. For FR4 substrates we got a return loss of about -14. Then gain. For FR4 substrate, the gain is nothing but describes how much power is transmitted in the direction of peak radiation to that isotropic source. For FR4 substrate, we got a gain of about 6.5 GP. Then VSWR is nothing but a voltage standing wave ratio. It is an indication of an amount of mismatch between an antenna and the feed line connected to it. For FR4 substrate, we got a VSWR of about 1.4. And directivity is the measure of the concentration of an antenna radiation pattern in a particular direction. If the directivity is higher, the more concentrated or a focused beam is directed by an antenna. For FR4 substrate, we got a directivity of about 8.3 dB. This is all about FR4 substrate. For a August Durite substrate, permittivity of about 2.2. The return loss is -12. Gain is about return loss is -12. Gain is about 8.5 dB, and the directivity is 9.5. These are the results which we found from our simulated designed antenna. While comparing these two substrates, FR4 substrate as well as August Durite substrates, we concluded that if we design a circular array antenna using August Durite substrate, we get an effective antenna using this August Durite substrate. These are the references we undergo. Thank you, sir.
Yeah. Hello, I'm audible?
Yes, sir, you're audible.
Yeah, fine, fine. What is the software you use for this?
Sir, we used HFSS software, high frequency structure simulation software.
Very good. So what is the frequency you had in mind for this?
Sir, we used millimeter wave frequency, so we used 24 gigahertz, sir.
Whether 24 gigahertz comes under millimeter wave or what?
Yes, sir, starting from 24. It's a millimeter wave frequency.
So you focused only on one frequency?
Yes, sir, we focused on. No, sir.
Why, what
just focus.
For 24, plenty of frequencies available within the millimeter wave spectrum.
Sir?
Why only one frequency?
Since we are starting this project, just tried for a single frequency, sir.
Okay. Can it be a multiband antenna? Can you make it as a multiband antenna? You have not done it, but can it be extended for a multiband antenna application?
Yes, sir. We make it sure.
Okay. What is the reason to compare two different materials, RT Dura and FR4?
Since there are more or use FR4 substrate, since it is cheaper, but while using August Durite substrate, it gives more efficiency than the FR4 substrate. So our aim is to design a circular microstrip patch antenna using August Durite.
Okay. Please go to your antenna geometry, your designed antenna.
Yes, sir.
For the 24 gigahertz frequency. Okay, this one, huh?
Yes, sir.
But how about the dimensions, the diameter of the patch? How did you decide?
Sir, we designed under some calculations, formulas referred from our base paper.
Fine. What type of feed you assume?
Sir, edge feed, sir.
Edge feed, okay. This is, okay. Edge feed in the sense what, using microchip or you assumed this is actual in here?
Yeah, microchip.
Microchip only, okay.
Okay, sir.
Okay, ma.
Okay,
One
sir.
last question is, can it be used for any potential applications? Can you just highlight this antenna for any of millimeter wave applications?
Yes, sir. Millimeter waves are commonly used in 5G communications. We can use this antenna for future 5G applications such as smartwatch, etc. Sir.
Okay, very good, very good. Okay, ma. Thank you.
Thank you, sir. Thank you, sir.
Niteshri, are you going to fabricate this antenna?
Sir, until mini project we undergo this simulation, but in our main project we may design this antenna.
Okay, okay.
Fabricate.
Okay.
Okay, sir.
Okay, thank you. Next presentation, 169, paper ID 169, a review on spectrum sharing techniques in 5G communication networks. Mrs. G. Gnanapriya, Ms. P. Nisha, Ms. K. Vishnupriya.
Good afternoon, sir.
Good afternoon.
Today we are going to present about a review on spectrum sharing technique in 5G communication network. These are the upcoming contents we are going to see. Introduction. 5G is a next generation mobile communication technology that offers more capacity and data rates than the previous generation, that is long-term evolution. Existing LTE and 5G new radio technologies will be improved and included in the 5G standards that are currently being developed. According to the International Telecommunication Union specification, a number of 5G application services has been identified. These are the few options available: EMBB, MMTC, URLLC, and fixed fiber like wireless access. Each user should expect a minimum data rate of 100 megabytes per second and a maximum data rate of 20 gigabytes per second. Inadequate spectrum resource is the most significant challenge and issues for future wireless communication applications. Cognitive radio is used to improve the overall spectrum efficiency of a network to reduce the spectrum waste in a temporal domain. Spectrum sharing. Spectrum sharing is nothing but a simultaneous usage of a specific radio frequency band in a specific geographical area by a number of independent entities leveraged through mechanisms other than the traditional multiple and random access techniques. Many spectrum using applications need more spectrum to cope with receiving demands. Here we can see the mobile data traffic. Traffic is nothing but here denotes a demand, which is increasing year by year rapidly. Spectrum sharing process steps. The spectrum sharing process consists of 5 major steps. Spectrum sensing. Spectrum sensing is nothing but detects spectrum holes and sense the presence of LU when the CU operates on a licensed band. Spectrum allocation. Allocation of a channel not only depends on spectrum availability but also depends on the internal and the external policies. Spectrum access. Since there are multiple secondary users trying to access the spectrum, their access should be coordinated to avoid colliding in overlapping portions of the spectrum. Transmitter-receiver handshake. After deciding a portion of the spectrum, the receiver of this communication should also be indicated. Spectrum mobility. If the specific portion of the spectrum is needed by a licensed user, the communication needs to be continued in another vacant portion. 5G spectrum sharing at various frequencies. At frequency lower than 6 GHz, sharing is possible. The initial 5G systems are expected to operate at frequency of 3.6 GHz. Due to the use of sufficiently large cell size for realistic development, data rates as high as 100 MHz are possible. Here we can see the licensed spectrum, shared spectrum and the unlicensed spectrum. The licensed spectrum and the shared licensed spectrum are individual licensing, where unlicensed spectrum is the general licensing. Licensed exclusive access to spectrum, which ensures the quality of service. Shared access to spectrum, which encourages the quality of service. Unlicensed spectrum, which is non-exclusive access. It is also unpredictable quality of service. Spectrum sharing paradigm that allows secondary users to access time-abundant spectrum holds or white spaces. Promises technologies to alleviate the spectrum scarcity problem, increase spectrum utilization. Overcomes two types of interference. Harmful interference caused by device manipulation, harmful interference caused by malicious users. The secondary users looks for available spectrum bands in a real time and temporarily use them for wireless communication. Secondary users continuously check the spectrum band to avoid interference with primary users and surrender to primary users, whereas the primary users start using a band. Functions of DSA: spectrum awareness, cognitive processing, spectrum access. Dynamic spectrum access is classified into exclusive use model, open sharing model, hierarchical access model. Exclusive use model is further divided into spectrum property rights and dynamic spectrum allocation. In hierarchical model, it is further classified into interface, spectrum underlay, spectrum overlay. The upcoming slide is going to explained by Vishnu Priya.
DSA models. There are three types of DSA models: dynamic exclusive use, open sharing model, hierarchical access model. First, we can going to see about dynamic exclusive use model. In this model, the
Nisha, kindly mute your audio.
Okay, ma'am. Okay, ma'am.
First, we are going to see about dynamic spectrum access. In this model, the basic structure of the current spectrum regulation policy is maintained. Services are granted exclusive use of spectrum bands. It introduces flexibility, which improves spectrum efficiency. Second, we are going to see about open sharing model. It is a common mode spectrum. Each and every user has equal rights to use the spectrum. It is applied for wireless services which operates in unlicensed industrial, scientific, medical radio bands. It has three types: uncontrolled commons, managed commons, private commons. Hierarchical access model is further classified into three: interview, underlay, overlay. Interview model, it differs from overlay and underlay DSA model. When primary user is active on the band, secondary user cannot access licensed spectrum band. Underlay DSA model allows secondary users to choose a licensed spectrum band regardless of which primary user is utilizing. Underlay DSA models have two approaches: UWME technology, interference technology. Overlay DSA models Even when the primary user is accessing licensed spectrum band, the secondary user transmit on it. It also have two approaches, channel coding and network coding. Non-orthogonal multiple access. It is one of the most promising performance improvement strategies in 5G in fifth generation. It also have two types of NOMAs. First one is NOMA power domain and second one is NOMA core domain. Here is an illustration. There are some key ideas for NOMA. All the users are served at the same time, frequency and code. Users with better condition get less power, and successive interference cancellation is used at the receiver. Here it is an illustration of OMA and NOMA. The graph denotes is of power versus frequency for three users, user 1, 2, and 3. NOMA downlink. Under NOMA downlink, the base station overlaps information wave for its service to customers. Here the diagram explains it. NOMA uplink. A control message containing power allocation information should be transmitted to the base station at the start of the transmission NOMA uplink. This time, base station uses SIC to differentiate between user signals. The best detecting sequence is to begin with the strongest signal and move on to the weakest. Here are some of the applications listed here. A high-speed mobile network is available. A 5G will transform the mobile experience, and also it is used in multimedia and entertainment, as well as internet via satellite. Cognitive radio network is used to improve spectral efficiency. The Internet of Things connects everything. Here the conclusion part. It is an overview of fifth generation spectrum sharing and its types, dynamic spectrum access and its models, and NOMA techniques. Cognitive radio still faces issues in dealing with licensed users and unlicensed users, and there is a need to avoid interference so that it can be used in a variety of applications. These are the IEEE papers we have taken for our reference. Thank you for your valuable time.
Yeah, good survey work you have done, fine. But anything you made an attempt to address any of the problems or challenges, features, to address the spectrum? Can you just quickly go to the title of your paper? Yeah, a review on spectrum sharing. Okay. Right, good. So what is that you have done? Like, what is your role in this? Have you addressed something towards spectrum sharing or anything towards communication networks, speed, something like that? Have you tried something?
Sir, we are going to do so.
Okay, just a survey you made so far, right?
Yes, sir.
Right, all right. A couple of questions. Why NOMA is preferred for this work? Why not conventional modulations, access schemes? What is the point in going for NOMA?
Sir, by all of this, I think NOMA is better to...
What way? Yeah, that's fine. NOMA is better, I understand. Can you give me any one important feature of NOMA compared to other existing modulation access techniques, MA? Or what is the difference between NOMA and OMA? Okay, can you just define throughput, which is a common terminology in spectrum sharing as well as in the communication, 5G communication systems? How do you define throughput? What is it actually? No, these are some of the metrics, right, pertaining to 5G communication networks. Or can you tell me, or can you just list me any two performance metrics in 5G communication? In terms of what metrics parameters you would assess the ability or you would assess the capacity of 5G communication networks? Like efficiency, is there any metrics?
Speeding.
Speed, Speed, right?
Bandwidth, sir.
Bandwidth, okay. So how do you compare bandwidth for 4G and 5G?
Sir, when compared to 4G and 5G, 5G network have narrow bandwidth, sir. So we can use easily, sir, with a faster speed, sir.
Oh, narrow bandwidth. Okay. Okay, ma. Thank you. All the best.
Thank you, sir.
Hello, Vishnupriya.
Sir,
Can you share about the techniques used in spectrum sharing? Do you have any idea about the techniques?
so we have mentioned the interview, underlay, and overlay techniques, sir.
Okay. So we kindly concentrate on this for your future work.
Okay, sir.
Thank you, sir. Next presentation, paper ID 198, a cost-effective transmitter and receiver for unmanned aerial vehicles. Authors Dr. S.D. Vijay Kumar, Mrs. G. Vijay Kumari, Mr. S.P. Sanjeev, Mr. A. Sivanyanam, Mr. K. Venkatramana.
Good afternoon to everyone. Okay, so we all know that unmanned aerial vehicle is commonly known as drone. It's just an aircraft without human pilot, or it may be called as an aeroplane or a helicopter. But we most commonly in most common days we use drone. Okay, UAVs are used for observation and tactical planning. It can
take 5 minutes, please.
Sure.
Give all the introduction, all the basics and all.
Okay.
Your contribution, if any, you can explain.
Okay, so what is the need for this project? Our title is cost effective transmitter and receiver for unmanned aerial. What's the need of the project? So we are currently using 433 megahertz or 2.4 gigahertz radio frequency for transmitting data, which is a transmitter and receiver for common drone. These transmitters and receivers are highly expensive, and these transmitters and receivers are limited to a certain range. So, and main disadvantage is only one transmitter can connect it to a receiver. So before using the transmitter and receiver, we have to bind the transmitter and receiver, and we will use it while on the air. Okay. So what is the proposed system? We use NRF24001 for generating and transmitting radio signals. NRF is a single chip integrated transceiver, which can be both used as a transmitter and receiver, which is cost effective. Okay. So along with this NRF, we are using a MCU and some passive components to make the RF radio signals useful and to make some connections with the flight controllers. So in this proposed system, we can use 2 or more transmitters, and which also increases the range of the UAVs, and it can reduce some disasters. Okay, so the data transmission speed in the NRF can be up to 2 MB per second. So this is the NRF 24001, and it supports 2.4 gigahertz ISM band, and it can act as both as a transmitter receiver, as I mentioned earlier. It uses enhanced shock burst for data transmission. It also uses GFSK modulation and demodulation techniques for data transmission. We can transfer the data in 256 channels, so we can use a wide range of communication. It uses CRC, cyclic redundancy check, to detect and correct the error during the transmission. It doesn't require much power, and it also has a standby mode to save even more power. Okay, so this is the block diagram of NRF module. As you can see, we have a transmitter module and a receiver module and baseband, which is combined in a single chip. Okay, so enhanced shock burst baseband engine is a protocol supporting two-way data packet, including which helps us to packet buffering, packet acknowledgement, and automatic retransmission of lost data. Okay. This is the pin configuration of NRF 24001, which is quite simple. It has just 8 pins, which makes it more easier to connect, and the VCC is connected to power supply, and the ground is connected to the ground. Chip enable and chip select not, master out, slave in, master in, slave out, serial clock, and IRQ. So these are the pins used in the NRF 24001. We will connect these pins to any microcontroller unit like Arduino, Pico, or ESP32. Currently we use Arduino UNO or Arduino Nano. So using Arduino Nano's MCU for RF system. NRF uses power management and RF synthesizer to generate these radio frequencies. In transmitter, we can connect with the joysticks and Arduino and NRF 4L01, and with the power supply, we can connect the transmitter. So in transmitter module in the NRF uses power amplifier, DX filter, and GFSK modulator to transmit the data. And in the receiver block uses low noise amplifier, RX filter, and GFSK demodulator to demodulate the signal received from the transmitter, and it will be, and the received signals are sent to flight controller so that we can make the. And finally, these are the applications. We can use the UAVs in medical, military areas and stuff like that. We can also use this concept to apply in the field of wireless mouse and keyboard, etc. We can also use it for commercial and house automation. Why it is better than the existing solution? As I mentioned earlier, the range of the transmitter receiver can be extended. The experimental result shows that the average range is about 800 to 850 meters. Each receiver can be connected to 6 other transmitters. While on connecting to 6 other transmitters, NRF uses priority method to follow the data transmission instruction. If the receiver receives 2 data from transmitter on the same time. Okay. The data retransmission time is about 130 microseconds. It uses TCP protocol, which is a better solution to keep the UAVs in the air if single data packet is lost. It has more power. Okay, so what next? We can also extend the frequency range of 2.4 gigahertz to 5.7 gigahertz by changing the synthesizer or the front-end module, which can give us more range to cover. There is no much difference in cost if we change the front-end module to 5.7 gigahertz. Okay, these are the references, and thank you for your valuable time and query.
Yeah, hello.
Yes, sir.
Yeah, good to see some hardware. That hardware you developed in your lab or what?
Yes, sir. Yeah.
But is there any limitation you face so far?
So currently, there's no limitations.
Can I see the title once again? Please go to the title. UAV. Okay.
Just. Yeah.
Okay. Yeah, that's fine. But what do you mean by this cost-effective transmitter? Like, what are you minimizing?
Sir, okay. Sir. Currently, we are using Fly Sky i6 transmitter. This is a 6-channel radio transmitter.
Okay.
The average cost will be about 3,000 or 4,000 rupees something. On developing this prototype, we have took only up to 1,000 to 1,500. Just 50% of the original cost.
And how about microcontroller?
Microcontroller, we are currently using Arduino Nano or Arduino Uno. We can also use Pico or ESP32.
Okay. But you had to use and check the results, right? Microcontroller.
Yeah. Yes.
Fine. Can it be for any specific applications? You have given a list of general applications. Fine. Can it be suitable for any particular application? Probably in future, whatever you have in mind.
Okay, sir. Let's say if the range of the drone extends to, I have mentioned the range of the transmitter is about 800 to 850 meters.
Okay.
So if it extends the range, we can also connect it to a second transmitter.
Okay.
So we don't have to travel or we don't have to face any disasters.
Okay. One slightly complex question I would like to ask.
Sure.
A couple of months back, we had an issue between India, Pakistan, and some drones
Yes. Yes.
all the way came from there, and it went back, right? Without any trace, it went back. And it was happening for 2-3 weeks or so. We were unable to track the drones. What was the reason for it?
Sir, maybe
we were not able to track them. So all the way, it flew up to Jammu airport, and it was able to pick some pics, and it went back.
Okay, sir.
Yeah, that was the issue. So what is missing with this actually in terms of what technology? Why we were not able to track those drones?
Actually, I don't get your question. So can you repeat the question? I'm not really understanding.
Have you had this issue some 3-4 months back? There was a problem in terms of drones flying from Pakistan to Jammu airport.
Okay.
Yeah, right. All the way some 10-15 kilometers. It flew up to Jammu airport, took some pics, and went back.
Okay.
we people were trying to track the drone, but we were not able to track it actually.
Okay.
Some issues in the technology what we have. So what is the reason?
It must be due to the automation, I think. Because if you are using a Wi-Fi connection or if you are using the radio frequency, we can be easily able to track the drones. Maybe it must be due to automation. So there will be no.
Yeah. No. This is an open problem. This problem is available in the source also, open source also.
Okay.
Right to address it. Right. None of our radars were able to catch it.
Okay.
So please check. Yeah.
Okay. Sure.
Thank you. Good luck. Bye.
Thank you. Have a nice.
Next presentation, paper ID 238, a 2x1 wearable periodical array antenna for IEEE standards. Authors Mr. M. Vinod, Mr. EA Muhammad Ali, Mr. V. Kausik, Mr. S. Tangapandi, Mrs. Lima Nelson.
Is it the last paper, ma?
Yes, sir, it is the last paper of the session, sir.
Please take 5 minutes because the meeting is due for me. Please make it fast. Yeah.
Okay, sir. Respected chairpersons, students, participants, and faculty members, good evening to all. Our topic is a 2x1 wearable periodical array antenna for IEEE standards P802.111AY D4.0 applications. I am Dr. E.A. Muhammad Ali, HOD. My teammates are Vinod, Kausik, Tangapandi, Lima Nelson. The content of our presentation is objective, introduction, design aspect, result and discussion, and conclusion. The main objective of this research work is to design and fabricate an antenna that is applicable for futuristic work. Okay, this is a next generation antenna design. Okay, and also achieve the compact size and high performance in terms of various parameters. Okay, so introduction of this research work. We know that in recent years, the process of wireless communication are increasing day by day, and microstrip patch antenna plays a predominant role in this modern era of wireless communication. The wearable microstrip patch antenna is a good choice. In this paper, now going to get into 5G wireless communication. Till early 2020, there is only two promising spectrums for 5G wireless communication. One is millimeter waves and other one is sub 6 gigahertz. At present, the other promising spectrum is added, that is sub 7 gigahertz by the ITU or added to IEEE P802.11 standards for 5G communication. In this research work, the proposed wearable multi-strip patch antenna is going to work efficiently in both sub 6 and sub 7 gigahertz frequency bands according to the IEEE standard. The proposed simulated and fabricated wearable microstrip patch antenna in this research work resonated at two different frequency, one at 3.74 gigahertz and 5.3 gigahertz frequency with a good return loss. As mentioned previously, the variable, so here the dielectric material used in this proposed antenna is cotton with a low dielectric constant, and is recent years the wearable antenna is blooming into modern wireless communication technology and also received significant attention of the researchers. This proposed work plays a prominent role in the field of military and medical applications. Okay, the electrical and mechanical properties of the substance materials are considered here carefully in designing the wearable antenna. Due to their foldable, stretchable and bendable properties, this wearable antenna is needed extensively in this modern innovative era. To achieve this, our aim to satisfy IEEE standard, the proposed design is implemented with various techniques and various optimization was carried out during the simulation process. In this research work, a deep study on techniques like array and split ring resonator SSR are taken into account. The proposed technique is nothing but it is a group of radiating patches placed in a single dielectric material. In recent years, array techniques in microstrip patch antenna plays a vital role and also attracted the attention of the researchers in this field of designing microstrip patch antenna. Implementing the array technique can achieve long range in the transmission of information with high data rates and high gain can be obtained. So the efficiency of the antenna is very high. It's due to steering of arrays. So the proposed antenna also obtained very high range of working efficiency in the transmission and also stimulated result proofs discussed in the further slides. The SSR is implemented to load the proposed antenna, and the split ring resonator is implemented in the ground plane of the proposed design is also explained in this work. Okay, design aspect of antenna. The overall dimension of the antenna is very compact size. This is 2.1 cross 2.1 cross 0.16 centimeter cube. Okay, here substrate is cotton substrate. The top view, this is nothing but a badge. This array badge is used. Okay, the figure shows the bottom view of antenna is SSR. Okay, this is a ground substrate. Okay, result and discussion. I would like to briefly explain about the various results. But the first one is a return loss. So these used for two frequency range. One is sub 6 gigahertz and sub 7 gigahertz. So at sub 6 gigahertz, the antenna resonated at 3.774 gigahertz with a bandwidth of 3.67 gigahertz to 3.78 gigahertz. And at 5.3 gigahertz here with a bandwidth of 4.17 to 5.41 gigahertz. So the return loss at first sub 6 band is 14 here at center frequency 3.7. The return loss is 14 minus 14.67. And the second one, at resonant frequency 5.3, the return loss is minus 22 gigahertz. The condition for achieving the return loss would be equal or less than minus 10 decibel. Okay, here the condition is fully satisfied at these two band of frequency. And the VSWR plot here, the VSWR plot here, the for first frequency for 3.74 gigahertz, it is 1.45. The condition for VSWR, it should be very near or close to unity. Okay, here we have achieved at these two frequency range. Okay, at this center resonator frequency 3.74, the VSWR value is 1.45. At 5.36, it is 1.15. Okay, so this Sumit chart shows the impedance matching of the resonant designed proposed antenna. So this provides a good impedance matching. The figure shows it very clearly. Okay, then the gain and directivity of the proposed work. So the gain and the maximum gain value is achieved by using this design. The gain is 4.6 decibel for both frequency range, and directivity of the antenna is achieved maximum here, that is 4.2 decibel. Okay, the efficiency of the antenna is almost equal to 100% at both frequency. It is at 3.7 gigahertz, it is 116, and at 5.3, it is 105. Almost 100% efficiency is reached. Okay, radiation pattern here, the proposed antenna provides linear polarization in 0 degree and co-polarization in 90 degree radiation. Okay, and another important factor, it is a wearable device, so it's close contact with the human body. So the SAR, specific absorption ratio, should be close to 0. So here we have achieved the SAR value for 3.7 gigahertz, it is 0.9, and for 5.3 gigahertz, it is 1.23, it is very close to 0. So it is no harm to the human body. And also another one important factor is the surface current distribution. Surface current distribution of proposed work is distributed evenly throughout the entire ground. The power consumed is very, very minimum. It is less than 1 watt. Okay, it is shown in figure very clearly. Okay, this antenna also fabricated, the front and back side view of the fabricated. The result will be analyzed using vector network analyzer. Okay, the simulated and this figure shows the simulated and fabricated result. Okay, the comparison between simulated and fabricated result. So the proposed antenna provide almost both results are almost equal. Okay, so I would like to conclude this entire presentation. The proposed antenna exhibits high flexibility, 0 SAR, high efficiency rate, and better performance. This antenna really suitable for sub 6 and sub 7 gigahertz applications, 5G applications. Thank you so much, sir.
Sir, any queries? Sriram Kumar sir, any question?
Hello, sir.
Yes, sir. Yes, sir.
So have you completed the fabrication process also?
Yes, sir. Yes, sir. I have completed all the fabrication and simulated process, sir.
Okay.
And I had done excellent study, detailed analysis also.
So have you obtained the 0 ACA here, sir?
Yes, sir. Yes, sir. Almost near to 0. For 3.7 gigahertz, it is 0.9. For 5.3, it is almost equal to 1.2 gigahertz. 1.2.
Okay.
Very close to. Yes, sir. Yes, sir.
Very good, sir.
Yeah.
Sir,
Yeah. Hello, Professor. Sorry, I missed your geometry because in between I got a call, official call.
no problem, sir.
No problem, sir.
Yeah. Can I have a quick look on your geometry?
Yes, sir. Yes, sir. This is
what is this
geometry of?
Okay,
sir.
Software. What software?
Sir, batch top view of the.
No, software.
Shows the top.
What antenna software used? Software.
HFSS, sir.
Very
HFSS.
good.
Yes, sir. And also fabricated, sir. Fabricated, tested. The result of the fabrication test result also done, sir.
Do you have the fabrication of? Yeah. Oh.
Yes, sir. Yes, sir.
Fine.
This is an excellent work, sir. It's a novel idea.
Very
It's
good.
an advanced technique, sir. It is almost late 2021 research work, sir. The sub 7 gigahertz is now only introduced, added with the standards, IEEE standard.
Very good.
So this antenna is also designed and fabricated for the sub 7 gigahertz frequency range, sir.
Very good.
So millimeter wave range, it's not suitable, sir. It's a very high throughput and high speed, etc. But that has one major disadvantage, sir. Millimeter wave spectrum, because the obstacles completely collapse the entire performance, sir. But that will be rectified by using sub 6 and sub 7, sir. So millimeter wave means that is greater than 24 gigahertz.
Correct.
The range greater than 24 gigahertz. Sub 6 means less than 6, sir. It's almost 3.3 gigahertz to 4.2 gigahertz.
Very good.
So next 4 to 5 gigahertz, it is a sub 7 range, sir. Okay, so this the comparing to a millimeter wave spectrum, this is very less speed and throughput, but this will be avoid the major disadvantage of the millimeter wave spectrum, sir. It can intrude the material, wood or other some material, so the obstacle cannot stop the signal, sir.
Okay,
so,
got it.
Yes, sir.
How about this VNA? Where did you use this facility, VNA facility?
Yes, sir. It's under the research. Yes, sir.
No.
My teammate, sir. He have industry, sir. Industrial person.
Oh, okay.
Mr. Vinod, sir.
Okay.
Research is also doing a fabrication and testing process, sir. Very more communication. Yes, sir. He done all the fabrication and testing work done by Mr. Vinod, sir.
Okay. Is it designed for multi-band or a single band, Professor, your antenna?
Two bands, sir. Sub 6 gigahertz and sub 7 gigahertz.
Oh, 6 and 7. Okay.
6 and 7, sir. Some advanced application. It's a future technology, sir. So now only it is booming. It's a future technology, sir.
What
is also? Yes, sir.
Substrate material you use for this?
Substrate. Here we use cotton, sir.
Oh, cotton is the material. Okay.
Wearable, sir. It's used for military and sensor applications, sir, mainly. The cotton, sir, with the dielectric constant is 2.3, sir.
Oh, 2.3. Okay. Perhaps you could have extended this for any one potential application. As you said, for military, you could have tested.
Yes, sir. We can use this for a lot of applications, sir. In mobile communication, satellite communication, any application. And especially these are wearable device, we can use this for biosensors and also medical applications. Essentially used for that application.
Very good. Okay, Professor, I'm done. All the best.
Thank you, sir. Thank you so much. Very kind of you, sir.
Please.
Thank you so much.
Welcome.
Thank you, sir. I extend my heartfelt thanks to Dr. D. Sriram Kumar for acting as a chairperson in Session 2 Communication System domain. Sir, I kindly request you to give the brief review about the papers presented in the session, sir.
Oh, okay. So there were 7 papers got reviewed. Yeah, some 3-4 papers on antennas. It was good to see, some amount of, some quantum of good work and new work in all the 3 or 4 antenna papers. Fine. It's, I'm basically an antenna guy, so I could see the work, quantum of work done in all those 3 or 4 works. And in addition to that, by and large, people are focused on these smart technologies like, AGV, unmanned aerial vehicle, Li-Fi, and something on 5G, 6G. Like a couple of them are focused on millimeter wave. It's all interesting. So nothing to be rejected. All are good. Only concern is, a couple of papers were focusing on complete survey. So instead, they can move further. Instead of moving, going for a survey related stuff, if they could do some sort of work, like they need not go for any hardware and all, probably they can go for, developing some algorithm, mathematical modeling, equivalent circuits. With that, they can claim their work also. So that is pending. So it is a suggestion for them. Probably they can take it forward and, visible work there actually. It will be colorful only then. Yeah, otherwise it's fine. On the whole, it's fine. I'm satisfied. Go ahead. All the best. All the best wishes to all the participants. Thank you.
Okay, sir. Thank you, sir, for your valuable comments. I would like to end up the session with a vote of thanks. Now I request Ms. Balakritika to propose vote of thanks.
Good afternoon to all and all present here. It's my privilege to propose the vote of thanks to the guests gathering on the International Conference on Smart Technologies and Applications, ICSTA 2022. First and foremost, I wish to express my sincere gratitude to Dr. S. Sriram Kumar for his presence. Thank you, sir, for giving valuable feedback about the papers. I would like to extend my thanks to Internal Chairperson Dr. Vaira Prakash sir for giving valuable suggestions. Then I thank all the participants who have present the paper. Thank you all. With deep reverence, I thank our principal, Dr. L. Ganeshan, for making this wonderful assimilations, and special thanks for your laborious effort and your great generosity for permitting this international conference. Thank you, sir. Then I interpret to thank our Vice Principal, sir, Dr. S. Rajakarnakaran, for his constant support for organizing this conference. Thank you, sir. Next, I extended my gratitude towards Dr. K. Vijayalakshmi, Organizing Secretary for this international conference, who helped us in various ways to organizing this conference successfully. Thank you, ma'am. My gratitude is also extended to Dr. S. Perenaiki, Head of the Department, Electronic and Communication Engineering, who constantly motivate us to conduct such events successfully. Thank you, ma'am. I also thank our faculty members for their tireless effort. Last but not least, my big thanks goes to all the participants for their active participation in the conference. Once again, I thank you all. Thank you.
Thank you, sir.
Dear authors, kindly fill the feedback form. All the authors need to fill the feedback form. Then only you can get the certificate. Individual authors all should fill the feedback form.
All authors are kindly fill the feedback form individually. Then only we have get the participation certificate.
I'm just leaving, Professor. I'm just leaving now. Is it okay?
Yes, sir. Okay, sir. Thank you, sir. Thank you so much, sir.